All right, grade 11s, this will be the beginning of our analytical geometry unit. And grade 11 analytical geometry, most of it relies on what we have learned in grade 9 and grade 10. So that being said, we're going to start with reteaching and relearning and reminding ourselves of everything we've learned in grade 9 and 10. And then we'll move on to actually applying all of that and adding in some new grade 11 stuff. So this lesson is just the revision part. I say just like it's not important, but it's probably the most important part is to revise everything that we've already learned so we can use it for the rest of this unit. Okay, so we're going to start here where we're talking about this triangle ABC, and we are just going to go back to how do we plot these points on the Cartesian plane. So first we need to have our x and y axes. So you're going to use a ruler, draw those in. And remember, we need to label our axes. And we also need to put in a scale. And I don't like to write on every single square because then it's going to look very untidy. So I mark off every second bar. And you can see I've placed my axes so that I would have enough space for the points that I need to plot. Okay, so we're going to plot these points. A is at -3 and 7, so -3 on the x up to 7 on the y. B is at -8 and 2, so B is all the way over here. I just barely made it for him. And C is 4 and 6. And now what we do is you're again use a ruler, connect your points. And we will have A, B, C. Okay, so we're going to use these, and we are now going to look at the different formulae. And this is why we're doing revision, is because I don't expect you to remember these from last year. So if you do, that's great. But if you don't, that's okay, because we're going to relearn them now. So the formula for distance, and you will either see distance written will have a lowercase d, and because we're looking for the distance between BC, then I'd like you to write d sub BC if that's what we're looking for. But here it's just straightforward. Distance, right now we're looking for a generic formula. So let's start by considering 2 points. So let's call them T, and T will be at x1, y1, and then V, which is going to be at x sub 2 and y sub 2. These have to be subscripts, okay? You can't use a superscript because then those are powers. So if you have a y with a 2 at the top, like this, that means y squared, okay? So don't do that. It's the subscript. So the distance is the square root y2 minus y1 all squared x2 minus x1 all squared. Now in grade 10, we would have started by showing you how we get this by using Pythagoras' theorem, but we're not doing that in grade 11. In grade 11, we just want to know what it is, and then we're going to use it, okay? So now what I'd like you to do is work out the length of BC. And we're leaving our answer in surd form, very important. And whenever we say surd form, I'd like you to leave it in simplest surd form, and your calculator will do that for you. So when we're finding BC, you can either write it as BC equals, or you could say D subscript BC equals. Okay, both of those mean the same thing. You don't need to do both. I'm just showing you that you could write it both ways. So those two symbols that denotes the distance between B and C, or the length of the line BC. From here, you should just use your calculator. I don't want to see middle steps and other little finicky things happening here. From this point on, it's your calculator. You need to have a calculator that can digest this kind of information, and you have to know how to use your own calculator, okay? So we put this whole thing into our calculators, and we get 4 root 10. And that's why I also mentioned that your calculator should be able to give you simplest surd form without any other effort required. And because they did not give us units here, you technically don't have to give me units back. That's important. If I give you units, meaning if the question gives you units, then you have to give us units back. But if the question doesn't have units, you don't need to. If you like to write something, you can just say 4 root 10 units and just leave it like that. Right, midpoint. The formula for midpoint, and we're still going to look at, we're just looking at these points, these made up points. I put there T, which is x1, y1, and V, which is x2, y2. That's just what we're going to use when we're talking about finding or writing out the formulae. Midpoint is denoted by an uppercase M, which is why when I give you questions, if I've made the question, I try not to use M as one of the vertices in a shape, because uppercase M should be just, when we're talking about analytical geometry, it should be exclusively for the midpoint. So the formula, and it's a point, right? So you're going to have x and y coordinates. So to get the x coordinate, oh, not over y, what am I doing? It's x1 plus x2 all divided by 2. And then the y coordinate is y1 plus y2 all divided by 2. So if we're going to find the midpoint of BC, and I've said this point is being called point P, then we're going to say P is, and we just have to add those numbers. So add the x values and divide it by 2. And add the y values and divide it by 2. And then you can just put this into your calculator to get your answers. Again, I shouldn't be seeing middle steps happening. And when we have it graphed, use that to your advantage. If you have a graph that you know is graphed correctly and to scale, you can kind of check, because if we had like P coming up somewhere over here, then we'd know something's wrong, right? So if our coordinates are way off and not even on the line. So when you have the visual, use the visual to your advantage. Okay, so in this one, we have P as saying -2 and 4, which is right in the middle of my line, which is where it should be. Okay, so that's important just to be able to use the visual if it's there. If it's not there, that's okay. All right, but if it is there, then just use it to your advantage. Okay, now gradient, I'm hoping that you guys have this ingrained, burnt into your brain from grade 9. How do we calculate the gradient of, or between 2 points, or the gradient of a line? Because remember, the gradient of a line is just between 2 points on that line. Yep. Okay, so gradient, yes, it's rise over run, but when we're talking about just points, so yes, based on my drawing, I could count, right, my squares and get my rise over run. But if I don't have a drawing and I just want to work with my points, very good. It's a y2 minus y1 all over x2 minus x1. And very important, gradient is a lowercase m. So do not use an uppercase m when you're talking about gradient, okay? Lowercase m is our symbol for gradient. So now we want the gradient of BC. So just like how we use distance and we said d sub BC, we're going to go m sub BC, which means the gradient of BC. And I have 6 minus 2 all over 4 minus negative 8. And again, just use your calculator. Let your calculator do the work for you so that you are not leaving yourself open to any mistakes. And your calculator should be able to give you a simplified version, which is what we always want. Whenever we give fraction answers, we always want these fractions to be in simplest form. Remember, not mixed numbers, but just simplest form. So the gradient is 1 over 3. And you could always test, right? So you can use this graph now to test and say, well, we go up by 1 and to the right by 3, and I'm back on my line. So I know that that gradient is correct. Okay, so let's look at a few other little things. They're not formulae, but these are relationships that we understood or we learned last year. So when we're talking about parallel lines, now parallel lines, what do you know about parallel lines? Yes, parallel lines will never meet. Parallel lines are the same distance from each other, but with respect to gradient in particular, what do you know about parallel lines? Very good. So if line 1 is parallel to line 2, then the gradient, so m sub L1, the gradients will be equal. And with math, these if statements, they go the other way around as well. So if you have equal gradients, then you know your lines are parallel, okay? So if I told you that line 1 has a gradient of 2, and line 2 is parallel, then you know that line 2 has to also have a gradient of 2, okay? The other way around, if I told you that line 1 has a gradient of 4 over 7, and line 2 also has a gradient of 4 over 7, then you know they have to be parallel, okay? Perpendicular lines, so if line 1 is perpendicular to line 2, then their gradients will multiply to negative 1. Another way of thinking about this is that their gradients are negative inverses, but usually the multiplication to negative 1 is the easiest one for students to use, okay? They both mean the same thing. So if I gave you two gradients, and if you see that when you multiply them you get negative 1, then you would know that those two lines are going to be perpendicular. Okay, or if I told you they are perpendicular, then you know that their gradients have to multiply to negative 1. Okay, collinear. We learned this as well. So let's think of the word like collinear. And when you hear the term like coworker, what does that mean? Right, it's like someone who works with you or works in the same place as you. So collinear means that they are on the same line. Okay, and we only test for collinear when we have 3, because 2 points will always be on the same line because I can just connect them with the line. But if they are collinear, then what we're doing is you want to test if the gradient between one pair is equal to the gradient between another pair. So you could go MPQ equals MPR, or you could test PR and QR, or you could test, like, you don't have to test all, right? There's combinations. As long as you are testing 2 pairs between those 3, then you would have had, if the gradients are equal, then you know your points are collinear, and if the gradients are not equal, then you know that your points are not collinear. So when they form like a triangle, that's not collinear, right? BA, the slope of BA, or the gradient of BA in this triangle, is not the same as the gradient of AC. That's how we actually get a triangle, right? Or you could say the slope of, or the gradient of BA is not the same as the gradient of BC. Then that's also why they are not collinear. Okay? All right, so that is all of the work, or all of the formulae and a few of the concepts that we learned over the past 2 years of school. And what you're going to do now is, so you've been taking this down with us, and so once you have that done, you are going to now work on the exercise worksheet. It's labeled there examples, and these are the formula you're going to use. Make sure you have all these kept safely so you can use them when you are working on these examples and the rest of our practice problems. And as you continuously refer back and apply, eventually these formulae will be then in your brain forever, and you will not need to have this reference page when you are writing any of your assessments. But remember, homework and classwork is not a test, and so I want you to use what we have available. And then eventually what you're looking at is something you can retrieve in your memory, and that's what you want to do when you're writing any of your assessments.